Hi guys, okay, so in part D it says, the end of one of its blades is labeled D. The height of the point D above the ground can be modeled by this equation. When T is 0, D is at its maximum height. So D starts up here. There. Let's say that's D at the start, and then he just goes around like this and around like this. Now we are trying to find P and Q. We're essentially trying to find this model. It gives us this value, which is going to be useful for part E, but for now let's just find P and Q. Now the first thing I want to find when I'm dealing with a model is what's its maximum and what's its minimum. Now its maximum, I'm going to write this down. Its max, if you think about it, is just going to be this plus this. But we know that this is 3.91, let's say. We know this is 3.91. And its minimum is just going to be this minus this. Because this is 3.91. This is the height of the blades. So think about it. Look, he's starting off up here, and then he goes down to here, and then up to here, and then down and up, and down and up. If we're just looking at his height, forget about him going around. We're just looking at his height against time. He's going down to here, then up to here, down to here, and up to here. So its max, his max is just, well, let's get out our calculator. His max is 8.20964. And notice, guys, I'm not rounding here while I do this. Plus 3.90964. It won't make a huge difference, I'm sure, but its max is 12.1193. 12.1193. And his min is, well, let's just copy and paste this. That's this minus this, which is 4.3. So his minimum is 4.3. Now I always suggest, guys, when you can, draw the graph. Let's draw a graph over here. So he has maximum. Let's draw the graph like this. So his maximum is going to be here. Then he's going to go down and then up. And I'm actually going to draw. Okay, let's draw. This is the. Hang on. This is just my. Let's call this time. This is my time. And this is my height. And this line here is going to be. Let's draw. Just trying to find a color here. Okay, this thing here is going to be 8.2. There. This is h equals 8.2 dot dot dot. That's this. It's the middle. It's this thing that is going down and up, down and up. So the graph starts here. Well, hang on. He starts here, then goes down. Then goes up, and then goes down. And that's obviously not a great graph, but you get the point. So now that I have that, I have the max and I have the min, I can find Q. Well, Q is this line here. Q is equal to max plus, it's the maximum plus the minimum divided by 2. Which is actually just going to be this. It's going to be Q equals 8.20964, which is 8.21 to 3 significant figures. And then P is the max minus the min over 2. But that is just this. It's the 3.90964. 3.91. So you might say, well, hang on, do I even need to do all this, Mr. Flynn? But I did it to show you kind of both sides to make sure you've kind of got a clear understanding of how this relates to the graph and relates to these formulae. But if you understand it, no, it's fine. I could have told you straight away that P has to be this because that's the amplitude. You can see, I can see that's the amplitude just from looking at this, and I can see that Q has to be this because that's that kind of middle line. So no, you don't have to show all that, but obviously it helps. Finally, part E, I'll just do it down here. Part E, it says, if the observer stands directly under point C, so imagine he stands here. If he stands there for 1 minute, point E will pass over his head n times. Find the value of n, right? So how many times is he going to go through that, go around and pass over his head? Well, I'd like to know how many times or how long it takes to do one full rotation. So one full rotation is equal to, and that would be our period, is equal to 2 pi over b. Remember I said we'd use this number in the next question? So it's 2 pi over, and just be careful guys when you do this because it's a fraction over a fraction. So I like to do a big line over a small line like this. And that actually is equal to 2 pi times 10 over 3 pi. If you remember our multiply and flip the denominator. These cancel, and I'm left with 20 over 3, which is, let me just move down here, 20 over 3 is 6.66 something, or recurring. But the question wasn't find the period, it was how many times is D going to pass over his head. So it'll pass in 6.66 seconds, it'll pass over once, then another 6.666 seconds, it'll pass over twice. How many times will it pass over if he stands for a minute? Because he says for 1 minute here, 1 minute. Well, I just need to see how many of these are in 60. So I'm just going to do 60 divided by, I'll do 6.666, that'll be fine. 60 divided by 6.60. You could have used obviously 20 over 3, but I just find fractions over fractions are a little bit annoying. Well, look, it's 9. It's 9 pretty much exactly. So it's going to be 9. Therefore, 9 times. I mean, even if it wasn't exactly 9, remember that's just how many times it takes to get back to here. So it's definitely going to have gone over his head. Even if you did 59 seconds, the answer would still be 9 because it would, after 59 seconds, it would probably be somewhere like here, but it would have passed over his head. So just a little tricky question at the end. Okay, that's that question done. I'll see you in the next video for the next question.